Okay, you had as your homework assignment some problems on number 5.14 the Whit book, and that began on page 124 and went through about the third of the way down on 125. So I ask you to do parts B, C, E, and G. Is that correct? Okay, so I didn't lie to you about that. Couple of words about homework before I get into that. Most of you did a really good job of again, the old math teacher in me says show your work, and most of you showed where the answer came from, either visually and or with the numbers from the table and how you subtracted or added whatever numbers together. So that's exactly what I mean. I appreciate that. A couple of other things I want to make sure that I guess I haven't requested this, but so I'm going to request it now, is when you send me a document, and I talked about a good thing being to scan documents into PDF format and send those to me, and that most of you did that, and that worked quite well. Some of you sent other formats. I was able to read those okay. You know, I had a couple come in Word, that's fine. A couple came in with something that I had to use Photoshop for. That's okay most of the time. If I'm not in my office and I'm looking at this on another computer, that may or may not work. So yeah, the PDF is the best thing, but so far I've been able to get to everything. One thing, however you do it, when you send me the image, put it in the Dropbox, put your name on it, please, because I get, you know, literally a couple dozen of these things at the same time if everybody turns things in at the same time. So I may have multiple documents opened up, and if I'm looking, whatever I'm looking, I need to make sure I'm giving credit to whoever's paper it is. Otherwise, I have to close the document, try to find it, see which file it came from, see who submitted it. And as I said about other things, you want me to be in a good mood when I grade this stuff. So just put, make it so I can just see your name on the on the page somewhere. Whenever you start submitting SPSS stuff, you can also, there's ways you can put your name on those documents. Well, we'll talk about that and probably give some examples here pretty soon. The other thing is, and it's not so much a big deal in online course as it has been when I was teaching this course face-to-face, but I do encourage you to work together. Some of you are doing that, and I think that helps. One thing I will ask, if you do your own work, show your own work. As the semester or the term rolls on, there will be some assignments where you'll have some options in what to do. So I ask that if you're working together, pick different options, and you'll both get more out of it that way, or 3 or 4, however many of you are working together. Sometimes you can do it, sometimes you can't, because we've got students spread out all over this at least 2 time zones right now. So, so I just say these things to so I can get the most out of the class. So that being said, let's look at these problems, and let me see if I can adjust my screen to show what I want to show. I'm going to put me down here. Okay. This scenario is, we've got some folks who have colds, and they are normally distributed, so we know that it looks something like that. Isn't that a great normal curve? And we know that the mean is 83 hours, so 83 is in the middle, under the highest point of the curve, right in the middle of the balance point. And the standard deviation is 20. So if standard deviation is 20, that means I'm going to go at 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below. So my marks are going to be 83, and then the standard deviation above is 103, 123 for 2 above, and 143 for 3 above. Below is going to go to 63, which is 1 below, 43, 2 below, and 23, 3 standard deviations below the mean. So that's the way the distribution looks, and the area under the normal curve is how many cases we have at those points. So the first thing I'm asked to do on A, it says what proportion of sufferers estimate their colds lasted longer than 48 hours. So 48 is about here somewhere. So I want to know what all that is. And there are two ways of getting all that. First of all, what do you need to know about 48? And again, if you're playing the home version of the game, you can weigh in by chat or activating your microphone and saying something audibly. Okay, so what do I need to know about 48? What do I need to do to it? I'm going to write a letter. A z-score. So I want to know what z of 48 is. Well, we know the z-score is 48 minus 83, which is going to tell us how far away from the mean that number is. And we're going to divide that by 20, which is a standard deviation. So I am going to get, let me get my slide rule out of my pocket here, because I don't trust myself to do some math in my head. So 48 minus 83 is minus 35. So we're 35 points below the mean. When we divide that by 20, I find out that that is going to be negative 1.75. So that means we are 1.75 standard deviations below the mean. Two things we can do with that. One of two things we can do. You can do it both ways if you want to. If you look at the magic table, the back of the book on page 530 and 531, we look to see where a z of minus 175 is, but we can't find minus 175 because of the symmetry. We just have the positive numbers. Therefore, I look to see what 1.75 is. And we can do it one of two ways. So if I look at the line, it says 1.75. That is on the second page and the left third of the table, just a few entries down, and I've got my B and C columns. I'm going to do it this way. I'm going to look at the B column, because that's going to tell me how much is between the mean and 48. So the B and C column is 0.4599. And so that goes in, that's right here. Now what can I do with that to find out everything I want to know? I know how much is between 48 and 83. And I want all that. Again, sometimes you've got more than you want, sometimes you want less, you've got less than you want. So in this case, what we have is less. What else do we need to do? I want all that 0.45, but what else do I want also? I want the entire right side, which we know is 50%. So I'm going to add 0.5, and I'm going to get 0.9599. So we're looking at about 96%. So what does the back of the book say as an answer? Does it say, does it go out to all four decimal places, or did it just kind of say about 96? Yeah, what's the... Okay, 95.99%. Okay, that's so almost 96% suffer at least 48 hours of symptoms. You're not going to get over this in a day, essentially. Your chances are pretty slim of it if these data are correct. So that's a good, almost practical kind of problem here. The other thing, the next one I ask, and I'm going to see if I can actually save my drawing. How do I get a bigger eraser here? There we go. Okay. Clean enough to start again. Just about. Okay, the next problem asks us, any questions or thoughts about the B part? Is that okay? That clear enough? Anything from home? Any questions? If you're watching the recording later, I like for people to ask questions because they're probably going to have the same questions you have if there are any. So I like to have live people to talk to, whether you're looking at this live or not. So looking at questions, part C of the question, what proportion suffered for fewer than 61 hours? Well, 61 is about right here. And I want to know fewer, so I want that shaded area. So the first thing I have to do, you've already answered the question, so I'll just take your same answer. I have to Z 61, or find the Z-score for 61. Now, right off the bat, I know it's going to be a negative Z-score because it's below the mean. So I expect that, because when I get the Z-score of 61, so I'm going to call it Z sub 61, 61 minus 20, no, I'm sorry, not minus 20, minus 83. Divided by 20. And again, back to my slide rule. So 61 minus 83 is negative 22. Oh, I can do the math. So negative 22 divided by 20 is negative 1.1. So it's 1.1 standard deviations below the mean. So go back to the magic table again and find the magic number from the magic table. I'm going to look up again 1.1. And you want to do this the easy way or the hard way? Let's do it the easy way. Okay, so if I look at 1.1, which is right at the bottom middle third of the first page. That's where my 1.1 is, not next to the last line. And I'm going to use the C column, because that tells me how much of the area is beyond that Z-score and the whichever direction it goes in the end of it. So 0.1357 is going to tell me exactly what I need to know. So I don't need to do anything else. So 13.57%. So about 13.5% of the people are over their goals in 61 hours or less. So we didn't have to have two steps there. Questions, thoughts, comments about that one? So far, so good? Amen? Okay. Moving on to part E, and let me see if I can clean this up again. Well, pretty much butchered that, didn't I? Whoa. That's not what I wanted to do. Okay. So the last two are between problems. And you'll remember we ended, I think, our last lesson on how some kind of common rules for doing what we call the between problem. So E asks for between 1 and 3 days. Or 24 to 72 hours. So 24 is going to be about right here. 72 is going to be somewhere in here. So what I want, what are your chances of getting over your cold between 1 and 3 days? Are my numbers right? 20? Yeah. Okay. Again, I don't trust myself. So what do I have to do first now? Now I've got to do z-scores for both of them. So I'm going to have my z of sub 24 and my z for 72. So the first one, 24 minus 83 divided by 20 is whatever it is. Negative 2.95. Again, keep checking me on these things. So the z-score for 72, if it's okay with you, I'm not going to set up the formula there. I'm just going to say 72 minus 83, whatever that is, divided by 20, and I'm going to get negative 0.55. Now, they're both negative. So the easy way, I think the easy way to do this is I'm going to get the B column scores or B column percentages for both numbers, both Z values, sorry. So the Z for 24, which is negative 2.95, so the Z for 2.95 is 0.4984. That tells us how much is between the 24 and the mean, which is 83. So that tells us more than we want to know. The magic number for the Z for 72, which is 0.55 or negative 0.55, is 0.2088. So that tells us how much is between that 72 and the 83. That's the part we don't want. So what do we do with those two numbers? Question is there a correct way to express the answer in decimal or percent? Either is correct unless it's specified that it wants it one way or the other. I tend to talk about percent for things like this because, you know, when I say X percent of coal sufferers do this, it probably makes a little more sense, at least in my mind, if that's not. So your bottom line is yes, as you say, or does it matter? No, it doesn't matter unless it matters. It doesn't matter unless you're specifically asked one way or the other. Okay, so back to my problem. What you're just telling me is that in this case I'm going to take more than what I want, which is the 0.49, throw away what I don't want, which is the 0.20. So I'm going to subtract, and I'm going to get oops, no, hang on. Don't look at that. 0.1896. So 18.96. Okay, well, about 90%. Is my math right? Yeah. What does it? Oh yeah, this is a 2. Yeah, thank you. I knew I couldn't talk and subtract at the same time. Okay. How about 0.2896? That look better. That's almost 29%. So about 29% are over it in 2 to 3 days, according to the data that we have. And again, what was our pattern in this case? The between problems, the numbers were on the same side of the mean, and we subtracted. So if they're on the same side, whether they're both on the negative side or the positive side of the mean, we're going to subtract. Now, again, because of the symmetry, it works the same either way. Gather. Ready for the last one? So this is also a between problem. Oh, did I skip to no. 24%. 2 and 4 days. Okay, I didn't do that one. All right, we're good. I'm about to get all the mileage out of this normal curve that I've as possible, probably. Okay, so between 2 and 4 days, which is between 48 and 96 hours. So 48, somewhere about here. 96, somewhere about here. So I want this shaded area. So again, I'm going to Z each of these numbers. So again, I'm just going to put, I'm not going to write them, I'm just going to make my calculator do the work. So the Z of 48, so I'll talk through it, is 48 minus 83, which tells us it's 35 points below the mean. And 35 points, we divide that by the standard deviation to get how many standard deviations. Oh, we've seen that number before. I don't remember what it is. That's okay. Negative 1.75. So that 48 is still 1.75 standard deviation below the mean. Hadn't changed in the last few minutes. So the Z for 96. Okay, 96 is 13 points above the mean. Divide that by the standard deviation, I get that is 0.65 standard deviations above the mean. The easy, direct way is to look at, again, the B column, because that tells us how much is between the mean and each of the two Z-scores. So for the first one, that negative 1.75, we look up 1.75, and we get that is 45.4591. That is this part. That's the same. That's the same. Oh, okay. No, to keep telling. Yes, 9. Yeah, thank you. Yeah, keep telling me. I used to work a couple of lifetimes ago. I was a math instructor at a community college, and I had a colleague, actually our department chair, who told his students that if he made 3 mistakes in a class, they were just going to dismiss class. You don't get that same deal from me. I'm going to make 3 mistakes before the first lecture is over, probably. So the Z of 0.65 tells me, let's see if I can get this one right, I get 0.2422. So that is the right part of that. The right part's a little smaller than the left part. So I want everything I've got there. I want the left part and I want the right part. So again, the rule of thumb that we came up with the last lesson was if they're on opposite sides of the mean, we add. So I'm going to add these. See if I can get any of the digits right here. 0.7021. Okay, yay, got that one right. Okay, so a little over 70% are going to be over your code in 2 to 4 days. Questions, thoughts, comments? Fair enough so far? We're good with this assignment. Okay.